Hey, I'm Micah Sweat with Diversified Printing Techniques. Here to talk about automation with a specific regard to pad printing, coming up with solutions for tomorrow's production environment. So first, it's important to think about the need. What are your needs, especially when it comes to automating and pad printing? Where are your struggles? What creates hindrances for you? We looked at two specific needs, especially for this presentation. One is the personnel side of things, and the other is the production side of things. So when you talk about personnel and in automation, it's important to think about the operator, right? Their availability, their cost, and their reliability. Um, First, we'll talk about unemployment. It's kind of a unique time right now with the pandemic. But before the pandemic, unemployment was really low, which was causing a lot of struggles for business owners and managers to actually find people to do production jobs. Um, and then now there's some unemployed. It's just difficult to find workers depending on geographically where you are in the United States right now. We're seeing very unique situations for workers depending on where you're at. I've got some customers who have an abundance of workers and not enough work, and others who have tons of work and nobody to run machines. So it's a very unique time in that regard. We're also kind of aging out, changing generations. There's more people retiring. The baby boomers are moving along to a retirement age, and our new workforce is not so willing to do factory work. So these elements combined to really create a need for employees. Then you look at the operator reliability. You deal with sick calls. People have things they have to take care of. People get sick. People have family issues. And then a whole nother element of that is the training and understanding. When we bring an employee in, we have to train them for that specific job. They need to understand how that job is done, what's required of them, how to do it properly, what's improper. And that's a time cost for management. And that's just something where you have to make sure that person understands. And that can be very challenging. And then, of course, that person, once they're on the job, they have to take breaks. We have to obey the laws and give operators breaks from their duties. They have to stretch their fingers, and they have to keep their bodies healthy while they're working. So these are things that are important, but it also interrupts and makes the workflow unreliable. And then an operator, when a person's actually doing the work, you have inconsistent output. So they may run at this rate for an hour and then a different rate for an hour, and then they eat lunch and they're sleepy. So you get really slow output. And then as it gets towards the end of the day, they're ready to go home. So you have just this inconsistent output from an operator. And then they stop for a shift change, which they have to do. And then you have a ramp up and a ramp down, or excuse me, a ramp down and then a ramp back up. So this again gives you inconsistent results in your production. Lastly, in this category, we're going to talk about the operator cost. An operator, there's a cost that we have to deal with. That operator has to be managed. We talked about the training before. There's a cost to that. And then the HR costs. They have to have an HR manager. They have to have a direct manager, maybe a supervisor on the floor. So this all stacks up to quite a bit of cost overhead. And then you have your cost of living increases that you have to keep paying. Certain states and areas are raising the minimum wage rate right now, which could be good for our society, but it really becomes challenging to pay somebody, $15 an hour when you've planned a job at $8. And then you have the healthcare and the benefits. These are all costs that stack up. Not good, not bad. They're there, and we have to consider them. And so these are good things to think about with automation. That's the personnel side of things. Now, if we go to the production side of things, we can think about, what is automation going to give us? Well, automation is going to give us an improvement of quality. We get a more repeatable process. Automation is going to load part into a fixture the very same way every time, whereas an operator may do it a little differently. And then when the PLC is running the machine, when a sensor gets hit, it's going to do this. If a cylinder opens, it's then going to close. And this is a very repeatable process. So you get very constant output. Um, and then the amount of touches, when you touch a product so many times, with us, it's the printing. You're putting ink on a product and it may not have had perfect time to cure. And then you have to move it to a different position to print another imprint. You possibly smeared the print. Well, if you do this 3 or 4 times and you don't mess up until the fourth time, you've got a major issue on your hands. So it's important to get those touches out. And what we can do is we can rotate the part or transition the part from this position to that in order to get all the printing done without all these different touches. And then we get a very good quality part, and it's consistent, and we don't have to worry about all these extra touches. Another thing that happens is you have to deal with demand, right? So there's been a greater demand for consumer goods in America, and you have more and more refrigerators or more and more automobile parts, and we're having to catch up with this. So when you go to automation, you can typically have a faster output. You can run more parts, um, and by just getting faster cycle rates. Another thing is there's been a demand for more local production due to political climates and shipping costs. It costs so much more to move product from China now or other places than it did 5, 10 years ago because the demand's higher. So if we're able to reshore these projects and use automation to keep the costs down, then we don't have to worry about these shipping costs to import. And then with the political environment, we've had a lot of tariffs recently, and that becomes a challenge for production. When you plan on bringing in some components from another country and you have to pay a higher tariff, it really affects things. So to be able to have your internal production handle this really helps instead of having to import, and you're able to take care of the new demand. Now, in automation, it's important to consider flexibility. Um, if we have a flexible automation line and that's able to do more than just one process, it's going to give us a whole lot better return for what we've done. The lifetime of products seems to be shortening so much as the consumer base grows and changes, and a younger base, they want new things more often. It really changes cycle life of a product. So if you have a flexible automation line that can handle more than one thing, you're going to be able to get more value out of that. And then it may be that you have to have faster output for this one, slower output for that one. So if we're able to have something flexible that can work with the demand of the customer, it just gives us a much better solution. Um, the big thing with automation is at the end of the day, there's typically quite a nice cost savings. You have less rework, you have more production, and you have less consumable costs. People might say, well, that's interesting. How do you consider that you have less consumable costs? Well, if you're not doing as much rework and you know that the parts that you're making are good, and you're able to run more product during the time of for ink printing, you have a pot life. And if we're able to get 10,000 pieces out of an hour or out of a shift rather, versus 8,000, my pot life's still dead, but I was able to get quite a considerable amount more output. So it cuts back on that consumable cost. So what is the solution for automation in regards to pad printing? There's 8 elements. The first is the feeding. Then you have the fixture. Then you have your pre-inspection. Then you have to potentially treat the parts. Then you're going to print the parts, cure the ink, vision inspect, and unload. So first we'll look at the feeding. There's so many different ways you can feed automation. You have robots, you have trays, you have vibratory bowls, and you have operators. So this is all the different ways you can get product to the printing machine. With the robots, something we've seen more and more of is direct from the mold. So your robot arm that's pulling the parts out of the mold can actually position the parts directly on the pad print fixture, and then you go straight to printing. So that's one method. Another method is that robot arm could put the parts on a conveyor. So, and then that conveyor advances the parts into the printing cell. Um, and that can be done with, if you have like multiple parts, like if there's 4 parts in the mold, then you set 2 parts down, reposition that tool and set 2 more parts down. And the conveyor then advances them in. And then you have like a vision system with a flexi feed. So therefore, you're just randomly bringing parts in. Vision system picks out where these parts are on the conveyor. And then a robot would have tie into that vision system and know where to get the parts off of that in-feed system. And then it would directly load those into the tooling. Another way of bringing parts to the system is with a tray. You can bring trays in that have an assortment of parts. I would say properly placed in the tray, or oriented in the tray, that then a pick and place or so forth can grab those parts. You can also have those trays stacked with a stack up, stack down mechanism, where we're presenting a tray of parts to our feeding system, and then we're able to take the parts from the tray to the fixtures. Um, you still have the good old feeder bowls, vibratory feeder bowls, or if it's a larger part, maybe a centrifugal feeder. Um, and these are great. The great thing about this type of process is it's fast. It's going to get you parts quickly and repeatably. The challenge is with these feeding systems, vibratory feeding systems, you kind of are stuck with what you got. So if you need to make a product today and you have to make a bunch of them, you got to buy a bowl for that product. If the product changes enough, you may not be able to use that bowl in the future. Or you may, if there's a new product that comes out, you have to have a different feeding system for that other product. So as great as they are, as fast as they are, the flexibility side of them is fairly weak. And then, of course, you can still feed automation with an operator. We have a lot of systems because feeding really can be one of the most complex parts of the automation. In reality, it is, because you have to have that part put on a fixture, proper orientation, seated well, and if it's not done right, it's going to fail. With an operator, you can have a lot of the process automated, but still use an operator to put the part into the system. And it simplifies the automation. The automation can still kind of keep the rate of the operator driven, but then you're automating so many other things, which we'll talk about as we advance. The fixture is an essential part of the pad printing. Regardless of automation or not automation, if there's not a good fixture to hold the part, you're not going to get a good product. The part's going to move while it's printed, or you're going to get the print in the wrong place. So tooling is crucial. When we automatically load the fixture, we can do it with 3 different methods. We have pick and place, we have a robot, and we have an end of arm tool. So the pick and place is very simple. You have cylinders. It's like a gantry system, if you will, where you're going up and down, picking up a part, go up, slide over, put it down on a fixture. Very, very simple. Same thing can be done with a robot. If we're working with a tray system, we may need that robot to have selectors where it can go follow a grid and pick up 4 parts in this row and 4 parts in this row. So that's where a robot could be useful. Of course, your pick and place could have servo on it, so you can have multiple stops along the way. So there's lots of different ways you can look at that. And then an important piece of whatever you're using, whether it's a robot or a pick and place, is you have to have the right end of arm tooling. That end of arm tooling could be suction cups, it could be grippers, it could be a combination of suction and grip. There's lots of ways to affect the part. A lot of times we use suction to put a part onto a system, but we have to be careful about using that suction on the output because it could affect the print area. So there's many ways of looking at that. What's really crucial with automation is that you use dead-on tooling with your system. When I say dead-on tooling, it's important that that fixture be very accurately put onto the system. A lot of times we use pens for this. So you have pens to locate, screws to hold down. The other part of a fixture that's really important is the mechanical lock. So with the fixture, we need to make sure that the part is going to be held, right? When the pick and place or the robot, the end of arm tool brings that part to the fixture, we need to let that have a little bit of tolerance, right? And that way it doesn't have to be such a precise and slow motion. We can maybe do it a little quicker and get it within a tolerance. Once the part has been placed in the tooling, then we can have a mechanical tool grab the part. So, and it centers it to be always in the right place. You can also do this with like a vacuum hold down might be necessary, because in pad printing, when the pad hits the part, we may disturb the part, and that's not something we want to do. So we want to make sure that when the pad hits the part, it's not going to disturb the part. So we do that with a mechanical lockdown or a vacuum hold. Like I said before, auto centering is perfect. We just want to make sure that there's something to always get the part in the right position. And that's part of the kinetic tooling where there's some motion. And then it's important with pad printing that we have support of the print area, right? So if we have all this great tooling and it's very precise, and we're printing on a dome and there's nothing underneath the print in that dome, we're going to get a lot of deflection when we go down and hit it with the pad. And so it's important that we support that print area very well. Something that works really good in pad printing is to have a dummy pad. So once the part's been put in the tooling, the mechanical or the vacuum or whatever has engaged the part, and we go to another section of the indexer, now we have a dummy pad hit that part. There's no ink involved. We're not printing. We're just hitting the part so that when we do hit part with the ink, the part's already been seated. We've seen this work really well in a lot of different situations. It's really important that when you're pad printing, you know that the part's in the fixture. If the part's not in the fixture, then we're going to end up with ink on the fixture. And then the next part that goes in that fixture might end up with that ink in the wrong place. So knowing the part's there is really good. And that way, as it processes through the system, all the actions that get done to it are actually done to the part and not to the fixture. Pre-inspection is also great. If we have an assortment of parts that we might be printing, maybe we're printing some kind of cap, and this artwork goes on the blue cap and this part artwork goes on the yellow cap, then we can have a color sensor to make sure that the yellow cap's there or the blue cap's there. Those sensors we use to verify the parts there, going back to that, can be cameras, where we actually camera inspect, or we can also just use like a laser sensor to make sure that there's something in that space. We can also look for part features to make sure that we're going to print the part with the hole in it, not the one without the hole. These are all situations that we run into where we're trying to verify certain aspects of the part. One thing that we've done with this, and it seems to work really well, is that you can also barcode. So you scan in the pre-inspection data from a barcode, and it sets the camera up for that part. And then the pre-inspection method is able to determine that it matches the criteria of the barcode. It takes more out of the operator's hands as far as setting up what's required. Treatment's really good for like polypropylene, polyethylene. Some of these soft touch materials we're getting into require some kind of treatment. And what's tricky with treatment is if you anticipate an operator being able to always remember to pre-treat the part, say they're doing it by hand, you're going to get very inconsistent or potentially skipped parts of that pre-treatment, and then you'll end up with field failures. So anytime we have a customer that with a project that needs pre-treating, we really encourage using that in the automation cell. Yes, it does drive up the cost, but not having a treated part in the field can be an absolute failure. So and a lot of times you see people using the chemical pre-wipes instead of Corona treat or flame treating, and that's just not exactly the safest anymore in our operations realm of safety that we try to work with. So we want to try and stay with flame and Corona treat and plasma treat. And so if we are able to tie it into the automation, then we're going to get a much safer piece. Now, of course, there's plants that don't like to flame treat, which typically tends to be the best way to flame treat. And that's why we are able to look at things like Corona treat and plasma treat. And our team, and any team you work with is going to have the ability to assess which treatment not only is best for your product, but best for your facility. Then you have to look at the deionizing as another way of pre-treat. If there's a lot of static in the part, it's never a bad idea to run some deionizing across the part so that when we do print, we don't get that spider webbing effect of the inks on the part. And then when we do pre-treat, we do have inks for pre-treated polypropylenes, but it limits the amount of inks that we have to use to get the best effect. Whereas if we pre-treat, then we broaden our scope of inks that we can use, and we're able to get more chemical resistance, more abrasion, better functional inks for the field. So now we're at the print station of our automation. And there's two things that you really have to ask. Is this decorating or is this marking? Sometimes they intermingle, but when we're decorating a part, we're really looking at it differently than when we're marking it. Markings for function. A syringe, that's a mark. Those marks are very important. If we get those marks in the wrong place, dosages would be wrong. So that's really important to consider. Decorating, it's about mixing colors together, and it's important to do that as well, but it kind of helps us scope what printer would be used in the automation cell if we know kind of what the end result is. Another thing to consider is the size of the product image. That helps the size of the machine. If we're printing a very small image, we can use smaller machines. A large image, you have a much bigger printer, and your cell has to be built around that. How many colors are we printing? That again drives, do we need a multicolor machine? Do we need multiple positions, one for each color? All these things have to be considered, and again, drive how we build this cell. We have different technologies of printers to consider, whether it's pneumatic or servo. Why would we need pneumatic versus servo? That kind of goes to the decorating and the function. Servo gives us some speed and some higher quality tolerances that we can work with. Pneumatic gives us cost and some functionalities just may not need servo. That ties to your accuracy and tolerance. It's really important that we know the accuracy and tolerance that you need with your print so that we scale the right machine for it. How many different products are going to be coming through the cell? How versatile does this print cell need to be? How versatile does the printer need to be? Something huge for automation is tape clean. If we don't have tape clean in our machine, it's really hard to automate. Your pads are going to pick up debris. Your pads are going to have ink left on them. And if you can't clean that off, it's going to create bad prints, and that's going to hurt your automation cell. Automatic viscosity controls. It's really important to keep that ink consistent during the 8, 10, 12-hour run. So if we have automatic viscosity controls, adding thinner into the ink at a prescribed interval, it's going to help us have more consistent results. Dead-on technology, very important for automation. When I take a plate out of the machine and put a new plate in the machine, if I don't have dead-on technology, I have to stop and re-register the machine. If I have dead-on technology, that image is going to be the same place on the cliche 1 as it is on 2 as it is on 300. So we always try and push using dead-on technology. And even if it's multicolor or multi-position, it's really important that we have that so that everything's pre-registered before you even get to the machine. Same goes with the pads. If I can willy-nilly put some wood screws in the back of a pad, it's pretty good, throw it up on the machine. Well, if I'm in automation, I'm doing a changeover, I need to be a little more accurate than that. So we like to use dead-on technology for the pads. We're actually using a metal base, tapped holes, get that pad in the right position every time. And a lot of products tend to need that in order to have good repeatable results due to some geometries of the part. Super important. We need to make sure that the ink is in a good state when it comes off the automation. We can use air, hot air, normal air, blow that across the ink, and that might hold the ink stable enough to pack out, depending on the pack out method. We might need to use UV, where we're flashing that ink with UV light, and that uses UV ink, and we're ready to do some assembly work if we need to instead of pack out, where that part has to get handled more. That's going to drive you to UV. And then you have flame treating. Sometimes you can flame treat the ink at the end and really give it that cure, and that can work in certain situations as well. You can have a conventional dryer where your automation just sets it on a conventional conveyor dryer, goes through a hot chamber, comes out the other end, drops in a box, and it's ready to go. A lot of times we'll even put a little spot dryer on an index table to give a splash of hot air on the part during that one station, and then it moves on to pick and place and out. Vision inspection. This is a crucial part of automation. If you're not inspecting the parts, you could make thousands of parts incorrectly, and then you have to absorb all that cost. Whereas if you have a simple vision inspection, just checking for, is the print good? A lot of times we'll set up zones and just verify that that zone is within certain percentage of tolerance. Really helps just as a good checker. Is the good print? Is the color of the print right? Is the location correct? How is the quality? Is the print complete? And then from that, we can determine where does the part go. Bad parts go in a bad box. Good parts go to the dryer, the conveyor, whatever we're doing with the good parts. So after we've inspected, now we can unload the parts. Very similar to load in, pick and place, robot. Are we going to put the parts in trays? Are those trays going to stack up and stack down or just roll out on a conveyor? Are we just going to bulk unpack? Is the operator going to unload? Again, all those elements of automation from the pre-inspection to the post-inspection, all can be done even if an operator's loading and unloading parts, and all the automation elements still work. It's just that we don't maybe have the money, or we have just a vast number of parts that we can't really justify using pick and places or robots to load and unload the parts. And then the bad parts can still get kicked off before the operator's there to touch them, and you're still only seeing good parts. Or it could be vice versa, where you're only taking good parts off and the bad parts come to the operator to be properly dealt with. Something else we've seen is you can't always trust an operator to deal with bad parts properly. So we have some situations where the bad parts actually get put into a lockbox. So it might be that the bad parts are so critical that it's most important that we keep those away from the operators. So those get put in a lockbox, and then a supervisor level person has a key to be able to retain those bad parts, sort them, understand what's going on. And that's important to think about too, is, we put on an automatic shutdown. If we pass so many bad parts within an hour or within so many cycles, then the machine will go into a shutdown mode so someone can figure out how to fix that. So in 2006, we presented this project to this customer. They had products in trays. They needed to get the parts printed and then put back in the trays. So in 2006, we presented it, looked good, didn't quite happen. So they were still taking operators to take the parts out of the trays, pad print them, or they were using some technologies that weren't quite as good as pad printing. So finally, a few years back, we were able to start a project with them, and it really just developed over time. Engineering sometimes happens best with a pencil and paper. Got the ideas on paper, went to the customer with those ideas a little more professionally presented. And then talking with the customer, we came up with a more elaborate idea where we actually had stack up and stack down on the system. And we were able to have like several trays of the product where each tray could get pulled out. So operators loading this side, the machine was unloading the process. You have robot taking parts out of the tray, putting them on the indexer. That indexer actually had to flip the parts over to get the print side presented. And then we pre-treated the parts, made sure all the parts were in there at that station. Over here we came and we printed the parts with a locking mechanism to hold the parts in so the pads didn't pull them out. Again, all these elements getting used. Here we had too many variants to actually program a camera, but we had a live feed camera so that an operator standing in front could at least look and see what was happening, make sure the prints looked okay. And then we had a little heat kicking on the parts to make sure the ink was tacked. Robot took the part, then we flipped the parts back over to the non-print side down. Robot put them back in the trays, and then they stack back up. So while they're stacking up at this position, the operator is able to take this stack out. So a lot of the basic fundamentals of what we've talked about are all seen in here. This great case study here, they're taking parts, putting them into this cell straight from the robot. We have locking mechanisms on the fixture to lock that part before the robot lets go. We have actually a pad here that's working to hold the part down while the printing's happening. So that's just kind of a hold down pad. And then these are neat machines. These are right angle machines. So they're printing from the side, horizontal printers. So we're printing the left side and the right side of the part simultaneously. As they come in, they're passing through a pre-treat station to get that polypropylene to the right dyne level. And then it comes back, that robot's been waiting, pulls the part out, and it's ready to go on to pack out. So these are just some of the general fundamentals of automation with pad printing. I hope this has helped clarify some things for you, hopefully enlightened you here, and if you're able to automate some of your pad printing operations based off of some of this technology.
This concludes today's Virtual Engineering Week sessions. Thank you all for attending. Today's content will be available here on our Virtual Engineering Week swap card platform for 30 days. Be sure to tune in tomorrow when we kick off the day with a fireside chat with Jane Chase, Executive Director of the Institute of Packaging Professionals, followed by our keynote on leading the change in medical device packaging advancements in packaging. There's also a full day of conference sessions on advancements in packaging, plus product and supplier information. Don't forget our virtual expo hall.